Welcome to Mahesh Maths classes. We make it easy, you learn it quickly. Pair of linear equations in two variables, part 3. Before watching this video, make sure that you have watched part 1 and 2. In this session, I'll be going to discuss about relation between the coefficients and nature of system of equations. What is a system of equation? The system of equations consists of two or more equations. Then how many types of systems are there? There are two types of systems depending upon the number of solutions of the systems. For example, if there exists at least one solution, or if a system of equation has a solution, then it is called a consistent system. For example, if you take this system of linear equations, these two equations are meeting at a point. In this case, it has one solution. Therefore, according to the definition, it is a consistent solution. And in the second case, these two linear equations have infinite number of solutions as they are coinciding with each other. We have learned about the number of solutions in my previous video. So here also there are many number of solutions, therefore the system is consistent. Suppose if there is no solution, then the system is called inconsistent. So if you take this case, in this case the two lines are parallel, they never meet each other, therefore there is no solution. So this type of systems are called inconsistent system. So do we have any shortcut to find whether the given system is consistent or inconsistent? Of course, yes. Let us see what is that. Suppose if a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 are any two linear equations. If you observe, both the equations are in standard form. That is in the form of ax plus by plus c equal to 0. So the first condition is the equation should be in the standard form. So then these are the conditions. If a1 by a2 is not equal to b1 by b2, then the system is consistent and it has unique solution, where a1, a2, b1, b2 are the coefficients of x and y. Okay, let us know more clearly about this first condition. Suppose you take these two equations, that is 2x minus y is equal to 2. This is not in the standard form. Let us write in the standard form. And the second equation, x plus y, this is also not in the standard form. Let us write in the standard form, x plus y plus 2 equal to 0. Now compare these two equations with a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So what are a1? a1 is 2, b1 is minus 1, c1 is minus 2. And what about a2? a2 is 1, b2 is again 1, c2 is 2. Now we know that by looking at the graph, there is one solution exists and it is consistent. Now we will check the condition whether a1 by a2 is not equal to b1 by b2 or not. Let us consider a1 by a2 and b1 by b2. What is a1 by a2 here? 2 by 1, that is 2. What is b1 by b2? Minus 1 by 1, that is minus 1. So clearly a1 by a2 is not equal to b1 by b2. So when this condition satisfies, then we can directly say that the given system of equations is consistent and also it has unique solution. Now we'll go to the second condition. So what is that? Again, the system is consistent and it has infinitely many solutions. So you take this. If you observe the graph, both the lines are coinciding with each other. Both the lines are coinciding with each other, and the given lines are not in the standard form. So let us write them in the standard form first. The first equation is x minus y is equal to minus 3. If you write in the standard form, is equal to 0. X minus y plus 3 is equal to 0. And the next one, 2x minus 2y plus 6 equal to 0. Already we have learned about the graphs. If two lines are coinciding with each other, there exist infinitely many solutions. And if there is exists at least one solution, it is called consistent. So these two are satisfied. We will check whether this condition is satisfied or not. So let us compare it with a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Then this is a1, that is 1. b1 is coefficient of y, that is minus 1, and c1 is the constant term, that is 3. And here a2 is 2, b2 is coefficient of y, that is minus 2, and c2 is the constant term, that is 6. Now let us consider a1 by a2 and b1 by b2 and c1 by c2. What is a1 by a2? That is 1 by 2. b1 by b2 minus 1 by minus 2, this is 1 by 2. c1 by c2, that is 3 by 6. So it is 3 ones and 3 twos, that is also equal to 1 by 2. And if you observe all the values, that is a1 by a2, b1 by b2 and c1 by c2, the fraction, or you can say the ratio of the fractions are proportional, or you can say a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This condition is also satisfied. So when this condition is satisfied, we can say that the given system is consistent with infinite number of solutions. Let's check the third one, inconsistent. Suppose you take this system. In this case, you know that there is no solution exists. No solution in this system. And also, these two lines are parallel. When there is no solution, this system is inconsistent. Now let us check this condition. a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. Let us take the equations in the standard form. 3x plus 2y minus 3 equal to 0. Next, second equation is 3x plus 2y plus 4 equal to 0. When you compare it with a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, then a1 is equal to 3, b1 is equal to 2, and c1 is equal to minus 3. This is minus 3. Then a2 is equal to 3, b2 is equal to 2, and c2 is 4. Now let us find out the values of a1 by a2. What is a1 by a2? 3 by 3, that is 1. Then what is b1 by b2? That is 2 by 2, that is also 1. Then c1 by c2, that is minus 3 by 4. So it is clearly a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. 1 is equal to 1 but not equal to minus 3 by 4. So when a system is satisfying this condition, we can say that the given system is inconsistent and the solution does not exist. Now let us check some equations, whether they are intersecting, parallel or coincident lines without drawing the graphs. Let us see. Here is the first set of equations. The first condition is whether they are in the standard form or not. They are in the form of ax plus by plus c equal to 0 or not. So yes, they are in the standard form. So let us compare it with the a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Then a1 is 8, b1 is 4, c1 is minus 4, and a2 is 4 and b2 is 2 C2 is minus 2. Let us find out the value of A1 by A2. That is 8 by 4. That is 2. Next B1 by B2. That is 4 by 2. That is 2. C1 by C2. That is minus 4 by minus 2. That is also equal to 2. Therefore, we can say that A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Just now we have learned three conditions. So, according to this condition, the given equations, the given lines are coincident lines. There are infinitely many solutions. Let us take the next problem. So, they are in the standard form clearly. So, find out A1, B1 and C1, A2, B2 and C2. A1 is 2, B1 is 1, C1 is minus 1, A2 is 3, B2 is 1, C2 is minus 6. Let us find out A1 by A2, that is 2 by 3, B1 by B2, that is 1 by 1, that is equal to 1, and also C1 by C2, that is minus 1 by minus 6, that is 1 by 6. All the three ratios are different. Therefore, A1 by A2 not equal to B1 by B2 is not equal to C1 by C2. We have learned about this condition. When A1 by A2 is not equal to B1 by B2, the system will have a unique solution. Means the lines are intersecting lines. The lines intersected each other. Standard form or not? So yes, they are in the form of ax plus by plus c equal to 0. Let us find out what is a1, b1 and c1. So a1 is coefficient of x, that is 1. b1 is coefficient of y, that is 4. c1 is the constant term in the first equation, that is 1. Then a2 is the coefficient of x, that is 3. b2 is the coefficient of y, that is 12. c2 is the constant term in the second equation, that is 2. Now let us find out the ratios a1 by a2, that is 1 by 3. Then b1 by b2, that is 4 by 12, that is 1 by 3. And c1 by c2, that is 1 by 2. So clearly a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. So in this case there is no solution. The system is inconsistent. Therefore the lines are parallel. Okay. So next. 5x minus 4y plus 8 equal to 0, 7x plus 6y minus 9 equal to 0. They are in the standard form. Let us find out a1 by a2. I am writing it directly now. This is a1 by a2, that is 5 by 7. b1 by b2, that is minus 4 by 6. Minus 4 by 6. If you simplify, you can write it as minus 2 by 3. 2 2's and 2 3's. Next c1 by C2, that is 8 by minus 9. This is C1 and C2. So that you can write it as minus 8 by 9. So clearly A1 by A2 is not equal to B1 by B2 is not equal to C1 by C2. We have this condition A1 by A2 is not equal to B1 by B2. Means the system has a unique solution. Therefore, the lines are intersecting lines. That both the lines intersected each other. If the system defines distinct lines, then that equations are independent equations. For example, if you observe this, see here, these two lines are different. These two lines are also different. Therefore, this system is called a independent system. Suppose if you take in this situation, so both the lines are coinciding with each other, means both the lines are same. That's why these two lines are called dependent lines. So these two, in these two cases, the given equations are independent pair of linear equations, and in this case the system of linear equations are dependent.